And hello everyone, welcome back to another C++ tutorial. So we are finally getting to the juicy bits of C++. You may have heard people say that C++ is the object-oriented version of C. And that is what we'll be talking about today. OOP, or Object-Oriented Programming. Now, let's start off with what is object-oriented programming. Now, it is when you think of things in your program like objects. For example, here we might have a car. Just excuse my terrible drawing skills. Now, when we think of objects in programming, then this right here, that would be an object. We can imagine this car into our program, so into our pieces of code. And that's the basics. That's literally what we do. We are just imagining this object into our program. And what attributes it has, such as wheels. Cars has wheels. Let's say 4 of them. Car has windows. Or even better, what about a book? A book has a lot of details about it. Now, what object-oriented programming allows us to do is take this book and extract the data from it. For example, how many pages does this book have? Let's say 44. How big is this book? Let's say in terms of height. That could be 150 centimeters. That's pretty big. Who is the author? Zach. Zach's the author. This is what object-oriented programming basically brings to the table for us. We can take this object right here and we can get or store, in a sense, structured data about that object. A lot of people overcomplicate what an object is in C++. But it is in fact incredibly simple. It's literally in the name. It's an object. If you can think of it, if you can touch it, it's an object. So let's create our first object. Now, to create an object, you need to start with the class keyword to create a class. A class is basically just an object, but it's a special name for it. Let's create a book, because why not? And there you go. You have created your first object. However, this object, it doesn't have any properties. So we need to specify properties. And these properties should be available to everyone. It should be public. So we need to specify public. Now, when we specify public, we're basically saying that anything outside of this book itself can use it. You also have private. And basically, when something is private, it means that nothing else inside or nothing else outside of this book can access it. So if I specify here in the public string std, string title, so like the book title, I can access this title outside of this book, and we'll get to that actually. But if I go here and I say int pages, then I cannot access these pages outside of this book. So let's go here and say book, and this is to user object, and then let's call it my book, because I didn't have any book names in my head at the moment. Now we have just created a my book object, and let's just add a semicolon there. Now we can access this title property inside of the book. It doesn't have a title yet, but we can access it by going my book dot title, and as you can see, it even autocompletes for me. But if I try to go pages, it will not even try to autocomplete it, because pages is private. Pages is only available inside of this book class. It is limited to inside of this. We cannot access anything in private outside of this book, unlike this title, which we can reference it like right here. But we can't do that with pages. And in the future, you'll see the benefit of this. But for right now, let's just do what we have here. Now with this, we can also set it and say speed of the dark. It's a pretty good book. I do recommend it. Now we have that. We can now also print out my book dot title. Now when we do this, we'll get speed of the dark because we can access the title outside of this book. If we were to do pages, not that this is allowed because it's a string, but even if I change this to 1, you'll notice it won't even let us run this program because there's an error. It is inaccessible because it's in private. But yeah, that is the basics of public and private, and we'll probably get back to that at some point. Cool. Let's build off of what we have. Let's also maybe add in author, because that is also something a book has. A book also has a number of pages we might want to know about. And there we go. Now here we can set all of that data if we wanted to. So you can just get the author and the pages. I think the author of this book was Alex Shearer. Like that. I don't know. I can't remember if that's actually him. And in the pages we can say 90. It definitely has more than 90, but you get the point. Now we are able to access any of this data inside of this book. We can now go here and say my book.author, my book.pages, and what, oh, my bad, let me just, there. Then we run this, we'll get speed of the dark, Alex Shearer, and 90. Cool. Next up, let's discuss, before we continue, or we are continuing, but next up, let's discuss the constructor. Now the constructor gets called whenever you create an object. So whenever you do this, then it calls a special function that runs, but only when you create the object. For example, book, and it's wise to call it the same as the class name because it's the constructor. Now the constructor will just run whenever you create the object. So whatever you put in here will be executed whenever you create the project. For example, creating book. If we were to run this, we'll get creating book. And the more books we add here, so 2 and then 3 and then 4, you'll notice it gets called every time. So creating book, creating book, creating book, creating book. So every time we create a book, it calls this constructor. Cool. You also have something called a destructor. Let's actually keep all of these. And a destructure is the same as an constructor. However, a destructor only executes after the object has been destroyed. So here we can go tilde and then the name of the class. And here we can say destroyed book. So whenever this object gets destroyed or relieved from the memory or whatnot, this destructor will be called. And if we were to run this, you'll see we get at the end destroyed book, because at the end of the main program, we are destroying this class or the object that use that class before we completely terminate the program, because that's automatically implemented. And then it will destroy the object and it will call this. You can use both of these to your advantage, such as when you create an object, you can make it take in a value and set those values for you. Same with if you use this right here. You can make it maybe relieve values or change states or something like that before you close or before this object gets destroyed. So to build on top of what I'm saying here is we could do something like this and say string title, and it should be std, and in here we can go std string author and then int pages. So now we can take in these values And we can set them once we call this constructor instead of setting them like this. Wouldn't that be so much better if we could just do them here instead of here? So now we can go title, but we now have a problem because we have two titles. Now you have two things you can do, and I'll show you both of them. First is you can call this one maybe something like underscore title because it is not the main title. And you can say title is equal to underscore title. And this works perfectly fine. However, more often than not, you'll not really see this method used right here. Some people do, and there's nothing wrong with it. But a lot of times you'll see this, and then author is equal to author. Now this right here is the same as saying this, but because these two have the same name, we can specify this to say this object we are in. That author is the one we want. And then this one is the closest one to us, because it will always default to the closest one to us. So if we were to say this, it's going to default to this closest one. It won't necessarily change this one. It might just change this one to itself. But if you do this, then you're saying, okay, no, I don't want this author. I want this author. This one right there. The one that's in this object. That is what we're saying. So these are exactly the same. However, this one uses an underscore in the name to differentiate between this title and this title, whilst this right here uses a this and then an arrow to specify the one we want. So these can be the same name. It's up to you which you prefer doing. A lot of people just do this. But if you are kind of confused with this and you can't quite get your head wrapped around it, then it's perfectly fine to just do this method because it's the same. They just have different names then. And with this one, you specify specifically you want to access this object's author. And of course here you can say this, and then pages is equal to pages. That's passed in. Cool. Now here with book, we can do this and we can specify our items. So speed of the dark, and I hope I spelled this guy's name right. And we paste that there, and then we have 90 pages. Just like that. And now we no longer have to do this. And that is because this book here gets called when we create this object. So it makes sense that if we want to create the object and do a bunch of things, we can just as well set the variables then and there by passing them in. Now if we save this, we can still access all of the items or all of the details inside of it, as you can see here. But now it's in a much more convenient way to put it. You can of course have multiple constructors. If you remember the function overloading section of our course. By doing this, and let's say we remove this one right here. And now we can say title is equal to no title, and then author is equal to no author. And in pages we can just say 0. Now I can give it default values. So if we don't specify these here, then we'll just get these default values. And these thises here are optional. The reason is because it's going to go for the nearest author, nearest title, and nearest page. And since we're not passing anything in here, these will be the nearest title, author, and page. But if you want to be safe, you could specify this. And that will be perfectly fine as well. But now you have two ways to define a book. You can either define it like this, and if we run it, we'll get what we expect. Or you can define it without this there and then add it later. And if you do that, you should just remove that. Now if you run it, no title, no author, and book destroyed. And here you can just say my book.author is equal to Jack. Now this will of course edit it, so now it says Jack, but it will still say no title and 0. And that is the power of the constructor and destructor in C++ and OOP. In the next tutorial, we'll be continuing with OOP because OOP is a pretty big topic and I'd like to not sit a whole 40 minutes on it in one tutorial. So I think this is where I'll end it. But in the next video, we'll split OOP into different files. And then you can start structuring your program in a way that you can easily access other objects inside of your files. But yeah, that is all for today's tutorial. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next C++ tutorial.